Hello everyone. In this video, I want to go over span and tree, just kind of high overview of span and tree, and I want to use the packet tracer um, in module 5. So packet tracer 519 to try to demonstrate some understanding of span and tree. So I want to walk to go over this packet tracers to highlight a few things for you guys to pay attention to when you learn span and tree. Now, span and tree is one of the major protocols at the layer 2. So it is very important that you understand this really good because in the exams, the Cisco certified exam, um, they want you to be able to answer a lot of questions in regard to span and tree. So take this chapter, one of the most important chapter. So read really well and ask me any questions that you may have about span and tree. All right. So with that said, let's go into the packet tracer. So the idea, the goal of this packet tracer is for us to understand span and tree and the purpose of it. So let's talk a little bit about span and tree. So the concept of span and tree is that it is a protocol that is prevent a layer 2 loop, right? You want to build your networks without network loops, right? At the layer 2 or even layer 3. For span and tree, its focus is on layer 2 loops. So when you think about span and tree, first we need to think about a network. A network, when you design a network, you should consider redundancy within your network, whether it's logical redundancy path or physical redundancy path, right? With redundancy, you're gonna prevent that single point of failure, and also prevents disruption to network services when you have one link that provide the network servers goes down, right? So you need a second link that could pick up that service, that network service. So that's your redundancy networks. And because with redundancy and the layer 2 networks, you run into you could potentially run into network loops, right? Due to that redundancy connections. So if we look at this 3 switches interconnecting to each other, right? So you can see from switch 1 perspective, it has 2 links. So if one link would have gone down, the other link would pick the service up, right? So because of the 2 links, you can see that with a certain communications like broadcast or multicast or some unknown unicast where it's flooded, right, to all ports on the switch, then some of those broadcasts or multicast or your unknown unicast could keep circling your layer 2 networks, right? That will cause your layer 2 loops. I would ask you guys to refer to sections or chapter 5 or module 5, section 1.6 to understand how layer 2 loops can be created, and how it is accidentally created within the network. So refer to that section within chapter 5 to learn more about loops, right? So again, the idea of spanning tree is to prevent loops, right? Um, for that concept of layer 2 loops. All right, so let's dive into the packet tracer. All right, so let's verify. Let's do part 1, and then will verify the connectivity from PC1 to PC2 using ping. So I'm going to ping from PC1 to PC2 to see if we get any connection. And we get a ping replies here, which is tell us that communications, it's good from PC1 to PC2. Okay, so let's look at the show span and tree command, and we'll look into what is asking here. So from switch 1, let's issue this command. So span and tree VLAN 1. Okay, looking at the interfaces here, we know interface gig 01 on switch 1 and gig 02 on switch 1. So the role of the interface is designate and route for gig 02. Now I want you guys to also pay attention when you go over this chapter 5 about the roles on the interface when it comes to span and tree, right? What is the root port? What is a designate port? What is an alternate port? Okay, so pay attention to that as well when you go through the chapter. So we can answer these questions here. We like to, for example, gig 01, the status is in the forwarding, right? And is it a root bridge? It is not. And so I want you guys to also pay attention to the concept of root bridge. When you read chapter 5, understand how the elections for the root bridge calculate. All right, so we know gig 01 is in the forwarding state and is not a root bridge. Gig 02, it is also in the forwarding state and it is a root row, but it's not a root bridge. So let's go to S2. So span and tree VLAN 1. So span and tree for S2 switch 2, you can see the port, it's all in designated, right? Which means it told me that this S2 is the root bridge. So a root bridge will have all designated ports, right? No alternate ports on the root bridge, and no root port on the root bridge. Okay, so that should give you the clue on which switch is the root bridge. Okay, let's look at switch 3. So switch 3 has an alternate ports and a root ports. Okay, so I want you guys to understand what the difference between the root port row, the alternate port row, and the designate port row. So go through that chapter, pay attention to understand the rows of the of spanning tree on the ports. All right, so let's move on to part 2. Okay, let's answer some of the questions. So the link light that you see in here, it's all green, and there's an orange. And if you look at what that orange interface indicate, that it is an alternate. An alternate port, it's in the blocking state, so it's not forwarding traffic, right? It's just there until the switch could determine there is a change in spanning tree topology, and if it needs to use this port, it will convert it into a forwarding state, right? So the alternate state, it's a blocking state. I'm sorry, alternate port, it's in the blocking state. So this question asks, what path will the frames take from PC1 to PC2? So I want you guys to see something on Packet Tracer. So if you look at the Packet Tracer here, if you go to simulations, right, and if you use this icon here, look like an envelope, it's called as symbol PDU. And if you want to see the communication from PC1 to PC2 and with path that the packet traverses in the network, what you do is you click PC1 as a source, click PC2 as the destinations, and then you hit play, and you can see the frame is now forwarding from PC1 to the network devices, and the network devices are forwarding to other network devices, and at the end it arrives at the destination. As you can see, the frame is traversing switch 2, get forwarded out to both interfaces, but because switch 3 has an alternate port, it's not really receiving that frame to forward further. However, on switch 1 gig 2, the frame has been forwarded to S2 and eventually to PC2. Okay. Now you see a bunch of frames going back and forth. What you can do is sort of filter a lot of this stuff out so you can see what you want to see. Anyway, just a quick example of a way that you can determine how a frame of a package had been forwarded through the switch. Okay. So once you're done with the simulations, you want to click back to real time. All right, so let's move to part 2. So part 2 is asking us to observe the operations of the spanning tree. So with that, I want you guys to refer to section 2 of chapter 5 for spanning tree operations. Make sure you read pretty well over that section. All right, so for this packet tracer is want us to open switch 3 and do a show spanning tree VLAN1 command, and then we want to delete the cable between switch 1 to switch 2, and basically we want to observe what happens when we delete this interface, this link here, right? What happened to this link between S1 and S3. Okay, so let's issue this show command. So right now gig 1, it's in gig 0 2, it's an alternate block state. So I'm going to go ahead and delete. So here's the delete options, okay, with that X. You want to delete this. And then we want to observe what happened to this link here. It will take a little bit of time to go through all these timers on the interface, right? Every interface rows and state have some sort of a timer. So pay attention to that when you read your chapter 5. So I'm going to pause the video for a second to see the interface turn green. Okay, the interface just turned green. So it took about maybe a minute, maybe a little bit over a minute. So look into the timer. You can actually calculate the timer when that alternate ports chain to designate port, right? All right, so I think that's concluded this packet tracer. What you just observed is the spanning tree play a role in the redundancy of the networks, right? So as you can see, one of the link has been cut, right? Have been disabled. The other links has now picked up the networks, right? Service. So the spanning tree is very critical within your network design. And again, this chapter is very important if you plan to take your CCNA exam. That's all I have for this packet tracer. Until next time, I'll see you guys on the next packet tracer.